Good afternoon, everybody. I'm the CEO and co-founder at CloudSigma. We're a public infrastructure as a service provider, and we're one of the three companies involved with ESA on these information as a service contracts. So when we were looking at putting together a consortium of companies and delivering services under this contract, we really wanted to do things a little bit differently and focus on the end user and work backwards. So we've been really looking at the kind of the top level, how can we build engagement with end users and also with people who would build services or want to build services using this data, and essentially break out of the traditional user base that Earth observation has been sort of confined into. And that means building accessibility, and also, of course, it needs to be sustainable. And that means having a workable commercial model. And I think that kind of one follows the other, really. So in terms of that, what we wanted to do was make things simple. So to give you an example, 10 years ago, the development of mobile phone apps was an esoteric activity undertaken by teams within telcos. Today, everyone can build mobile phone apps. Well, why is that? It's because Apple and then later Google built easy-to-use frameworks, which meant that developers could then use mobile phones to develop applications and services. So that's the framework. So the framework shouldn't be underestimated. So what we wanted to do, and when we brought these companies together, was build a very powerful framework that didn't need you to be an Earth observation scientist to actually use the data. And so that's what we did. We tried to bring together people that can build up that stack that allows the user to engage at various levels. And then, as I said, it's about also being quite agile and putting out a service, even with basic features, and then getting user feedback. And that's also around the commercial model as well. We don't want to sort of sit in a darkened room for 3 months and then come out with what we think is the final product, when really it's never going to be the final product. So these are the companies involved at the different kind of value chain. And I wanted to kind of go into a little bit more detail to explain how we build it up. And a critical thing is that the end user of the services or the data can enter at any level in this. So they don't have to enter at the top. So they can mix and match and combine. So just to explain the roles of the different companies, you have CloudSigma, we're an infrastructure service provider. So we're providing the base framework. And then what we've done is we've built automated scripts to pull in the Sentinel-1 data. So we already have that running and building up an archive within CloudSigma. And of course, in the future, we will also have other data sets that we'll add into that framework. And we already heard about why it makes sense to put a lot of data in the public cloud. And then we come to the layer where I think that's really under addressed today in terms of what you can do, and that's bringing in a framework which can transform that data, which you have to be an Earth observation scientist to understand, into something that's usable, so that you can make simple queries, for example. And so FluidOps and their tool, which was built through an EC-funded project called Optique, which is open source, have a whole framework for building what are called data ontologies, which sit on top of the data and allow you to interoperate between all sorts of different data sets. So the idea is FluidOps does the hard work, and they actually take this data and different data sets, and they actually build a framework on top of that. And then as an end user or someone building a service, you can come in at this level, if you wanted to come in at this level, and build queries on top of this. And you don't have to understand Earth observation data to do that. That's the whole idea. In fact, they have a visual query tool. You don't even have to understand SQL or databases. So it's really, even like a dummy like me could actually come in and basically formulate a question and get an answer from the data sets. And that's very powerful because it makes it accessible. It democratizes Earth observation data. And if we do that, that will create jobs and innovation. And that's really the aim here. So that's that layer. Planetech are providing a solution around flooding. We heard a little bit about the challenges of flooding already from Atos, and we're building a service around this, which I'll speak about. And that's an example of a service that's being built on top of this framework. So the idea is that in the future, you'll have many different services at this layer. And then finally, you have Cloudeo, who have a very powerful marketplace, which is a kind of discovery engine, essentially, for people who want to find different services. And so the power of this is that by the way, we host the data for free and we expose it to all the users. So I could come in, sign up for a CloudSigma account, and basically access the data directly as a scientist. But I could combine that with a service that I found through Cloud.io and make a whole new service off the top of it. So that's really the idea. You can mix and match and combine. And so the idea is we're just trying to create a fertile environment, and we're not trying to predict what users will want to do in terms of the services and things like this. We're trying to empower the user to be able to build the services easily themselves, which is kind of a little bit of a different approach. So that's kind of the concept. And of course, there's a value chain here in terms of money, and each layer is adding value and adding cost, I guess you could call it, or value to the chain. So if you engage at this level, of course, you're getting an end user product. But if you're engaging at the data level, then you're getting the raw data and doing more of the work, and it's cheaper. And that's really the idea, and it's sustainable from this perspective. It makes sense for us to host and provide the data, and it also makes sense for each one of these layers above that. Finally, you can lift this stack up and stick it on a different infrastructure platform, so it doesn't have to be specific to CloudSigma. And the Fluid Ops could sit on the ESA data sat in another location, or they could build it out on another data set. So a lot of these tools that we're using are open source, and they're transportable. So this framework could be used with other infrastructure platforms, or et cetera. So you can essentially lift this stack up at various levels and drop it down on a different environment relatively easily. Not without work, but there would be relatively easily. So this is kind of the complication bit, which is the going from the data, which is Earth observation data, into these kind of more simplified interfaces. And this is a kind of blown out view of the sort of thing that Fluid Ops does. So normally you'd have to be delving into all of this kind of queries and things like this at the bottom to be able to build a service. And that's a lot of investment of time and work. And it's not very accessible if you really don't know the field. So this, for me, would be impossible. But when you add these query building tools, including visual query building tools, on top, you can easily engage, and you have these ontologies, so you don't really have to understand necessarily the relationships and what each thing means, because that's already been, so essentially these are kind of like crib sheets, and you engage at this level. So you can make a query that says, I would like time series data on these coordinates for the last 5 years. And it might be pulling in 2 or 3 different data sets using these ontologies and mappings that have been pre-created for you. So you can then come in and be like a lot, essentially the barrier to entry is a lot lower. So this is the use case. It's about flooding. That's our first use case. And really, I don't really need to explain why flooding is a problem. So really, it's like how to deal with the aftermath of flooding, because the satellites, they're not real time. They're not sort of spy satellites. They're actually satellites going around the Earth. So it's more about impact assessment, things like this. So you get insurance claims, you get farmers who claim damages, all different things like that. And this enables governments and other people to actually do damage assessment. And of course, it also, when they see the impact of a flood, they can better prepare for the next flood and say, okay, we got this wrong, we should amend this, et cetera, et cetera. So these are the sort of tools that we can put in the hands. And the great thing is, we're doing it in Europe, but actually this service could be used anywhere in the world where there's flooding. And there are a lot of places with flooding. So this is an export that Europe can give to the rest of the world and actually bring and create jobs and value here in Europe, in the European economy. So where next? So we will expand the use cases within this framework. We have a number of other ones lined up through the partners like Cloud.io, who already have engagement with various parties. And we will also build other value-added services like alerting and things like this. You imagine if you're an insurance company, you want alerting on a building, you insured an office building for 100 million euros, which is not unusual. You kind of want to know if there's some subsidence happening in the area or some problem. And you could be proactively alerted, and you would pay money for that if you're an insurance company. That's exactly the sort of thing you want to do. So these are the sort of services that we can build on top. And really what we want is developers, like normal developers, people that aren't specialists, to just come in with ideas like that from their own industrial backgrounds and say, oh, I know I could use this data for this in financial services or healthcare or whatever it might be. And we can't even imagine what those things might be through our sort of limited imagination. And the idea is that we have that framework. And so that's really the focus of the project. That's it.